Interpreting and writing skeletal structures. Have you got it? This short video quiz assesses your understanding of standard organic chemistry skeletal or line structure drawing, such as shown on the right, and your ability to translate condensed structures, such as CH3CH3, to skeletal structures. The quiz consists of 3 questions. It's meant to be taken after you have studied the material and think you understand it, maybe before a quiz or an exam. During the presentation, you'll be asked to pause the video, to at least try to solve the problem yourself, and only then to continue. It won't be hardly as effective if you jump to the solution immediately. Okay, here we go. Number 1, on the skeletal structure below, draw in all hydrogen atoms and lone pairs. What is the molecular formula of this compound? So pause the video while you answer this question, and then start it up when you're ready. Get out a piece of paper, write it all down. Let's see how you do. Okay, here we go. Let's find all the carbons first. We've got 1 here, 2, 3, 4, 5, 6, 7, 8, 9, 10. So the formula is C10 something. Let's get the hydrogens on there. Each carbon has to have 4 bonds to it. So these aromatic ring carbons each get 1 hydrogen, except this one right here, which already has 4 bonds to it. Our carbonyl group here, C with a double bond to O, already has 4 groups. This is a CH2 over here. This one's okay, and then up here at the top, we have need for 3 hydrogens. And this group over here is a carbon with double bond and 2 hydrogens. We call it a methylene group, and that's all our hydrogens. What do we got? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 hydrogens. We also have a nitrogen and an oxygen. Let's not forget our lone pairs. There's a lone pair on the nitrogen to fill it out and have 4 pairs of electrons around it. And the oxygen, double bonded oxygen, will need 2 lone pairs. So there we go, C10H11NO. And by the way, this is the way we typically write the formulas of organic compounds. We write the C's and the H's first, and then we follow that with the heteroatoms in alphabetical order. You don't have to do it that way, but that's sort of the convention. Okay, let's try number 2. On the skeletal structures for the ions shown below, draw in all hydrogen atoms and lone pairs. Again, pause the video, take out a sheet of paper, see if you can do it, and we'll talk about it when you start the video again. Okay, for the first of these, we have in this case 1, 2, 3, 4 carbons. Here we need 2 hydrogens. Here we need 1 hydrogen. This one's 1 hydrogen. And is that it? I think so. We don't have to worry about any other atoms, just the carbons. And there are only 3 carbons that need hydrogens there. Okay, how about over here in the middle? We got a lot of CH3 groups. We call those methyl groups. 3 hydrogens on each of these ends. Is that all of them? I think so. We have 2 CH2 groups, these broken lines here. what else? Two CH groups here, right here and right here. And on the one on the right. Okay, so here we have two ends. So we have two CH3 groups, one here and one here. And what do we do about this one in the middle? Well, if it didn't have the charge, that would be a CH2, but it's got the charge. And that charge represents basically a lone pair. And so that takes a third position, and we only add one hydrogen. Now, the problem requests that we get all the lone pairs in. It's a pretty messy lone pair. And so around every oxygen, it's doubly bonded, kind of the typical oxygen with two lone pairs. Here's another one over here. And then the oxygens that have two single bonds, same deal. Two lone pairs there, two lone pairs here. Sulfur is just below oxygen on the periodic table, so it also is going to be just like oxygen. And this guy over here, this oxygen with the minus charge, once again, the minus charge represents a pair of electrons, and then we have to add two more. So we have to complete this octet around that oxygen with three lone pairs to make a total of 8 electrons around it. Okay? Okay, here's a little challenge for you. Draw a skeletal structure matching the condensed structure shown below. Good luck. Again, take out a sheet of paper, do this, and then pause the video while you're doing that and continue it, and I'll help you out with it. Okay, here we go. Looks pretty messy, huh? The way I would approach this is try to find a chain. So we can start with the chain. That's called the backbone, and then we'll put all the different things around it. So here's 3 CH3 groups attached to this carbon. Here's another carbon. Here's another carbon. This whole piece here is a branch, and a carbon, carbon. The OH here is connected to the carbon, but not part of the main chain. Here's another carbon. Here's an oxygen. This is a little weird. Here's a CO2 and a C. Now, the CO2 here, something to think about. I bet if I asked you to draw the structure of CO2, you'd probably get it right. An oxygen with 2 bonds to it, carbon, and then another oxygen with 2 bonds. But this CO2 is embedded in a molecule. And what's happened is the center carbon has an oxygen attached to it. And this oxygen over here, there's only one bond to the oxygen down here, and there's a CH3 attached to it. So basically what that's going to look like in our structure is something like this. Okay, so let's see how long our chain is. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 atoms long. Now, big tip, always say the number 1 when you put your pen down, because that's the first carbon. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. On this first carbon, I have 3 CH3 groups. Second carbon is a CH2. The next one is a CH, and it has this branch, which is an alkene, like that. The next carbon is a CH2, and then the next carbon has the OH. So we're going to put the OH down like this. And then there's a CH2, and then there's an oxygen. And then here's our CO2 coming in here, like this. And then it's capped off with a methyl group. You can probably draw that a lot prettier than I can, but that'll work. I could understand that if you drew it exactly like this. Okay, so there you go. Remember, skeletal structures only hide carbons and the hydrogens that are attached to those carbons. If you actually drew the letter C, you would have to write the H's in there as well. And hydrogens connected to heteroatoms, nitrogen, oxygen, sulfur, for example, are always shown. For atoms with no formal charge, we assume 4 bonds to carbon, 3 to nitrogen, and 2 to oxygen. And when you're adding hydrogens to a skeletal structure, remember, you're only going to add those to carbon and look out for formal charges. The nice thing is that the formal charges at carbon always indicate that there's one less hydrogen at that carbon. And by the way, it's a good idea to draw a circle around your charges on skeletal structures, especially if you're a beginner, because otherwise your instructor could misinterpret that minus sign, depending on how you draw it, as a CH3 group, and a plus sign for what we call a tertiary butyl group, a CCH3 3. Thank you very much, and I hope you got it.